Yeah, welcome to today's IFT research call. Today, Ekaterina and Ugur will present Zerokit version 0.8 and its applications. So this version of Zerokit brings WASM support back, and I just wanted to give a shout out to Vin here, who is a new CC and ACZ, and he helped a lot with making this possible. So thanks a lot. Obviously, Katerina and Ugur also did a lot here, but wanted to especially give a shout out to him. So yeah, Ugur and Katerina, the stage is yours.
Yeah, Katerina can start first, I think. Then I can.
Oh, yeah, sure. Sorry, I just have some connection issue. If in any moments you can hear me, let me know in Discord, because today sometimes it's something wrong with connection. Okay, cool. So, hi everyone, I'm Ekaterina from ACZ team. I'm starting first. Today, me and Ugur, we will talk about Zerokit in general way, and also about new release. It will be my part. And next, Ugur talk more about applications of Zerokit and some new theoretical research around it and Erlang itself. Okay, let's start. What is Zerokit? For some, it's a collection of some models written on Rust for zero knowledge. The most important one is Erlang version 2 implementation for now, and for support we have Merkle tree implementation with two different approach, and Poseidon hash implementation, which we use in Merkle tree. What is Erlang it is? It's the key protocol which helps us in short way identify and kick the spammer. And also, Erlang can be used not only to prevent spam attacks, but in general way to limit users in some anonymous environments, and we can limit not users but number of their actions, for example, voting. Generally, the flow of Erlang can be described by the next steps. First one, user registration. So we have some new users, we have identity of these users, and we store this identity in Merkle tree as lifts. And that means users later can obtain a Merkle proof, proving that they are part of the group. The next part of protocol is sending message. So, and for every message or signal to other participants, users generate a zero knowledge proof by using Zerokit, and for the generation for this proof, they also apply proof from Merkle tree. And the last one is proof verification and slashing. As I said before, Erlang helps us identify and kick the spam. So we have mechanism when we verify, and we have same message with the same parameters, like same identity, maybe same message ID. We can easily retrieve user identity and kick it. Okay. What about Zerokit? So in Zerokit, we implement Erlang version 2. That means we can set limit like X message per one epoch. First version was one message per one epoch. And let's talk about what Zerokit includes and bring new and what we bring back to Zerokit version 0.8. The first one is stateless Erlang. We actually did it like some version ago, but it's really important because it's low. What it is at first? Okay. As I said, we need to have a Merkle tree to store user's identity, and before it, we did it on Zerokit site. So you use Zerokit like a full model. You can ask to generate some identity, and then you ask to generate proof and verify, and you didn't think about how Merkle tree store, how to store identity. We all did on our side. Now we also support stateless feature, because, for example, if you wanna store your tree on chain, we have duplication of tree and it's not efficient. So now we provide two different state of Zerokit. One stateless. That means you handle all tree operation, you handle tree, you just provide for us all necessary information for generate proof. And for verify proof, you also provide pass from the tree. And for this one, we have two different Merkle tree implementation. Only difference is that for full Merkle tree, memory is not so important, and operation speed is critical. We use full Merkle tree for situation when memory is not important, but speed operation is critical. And optimal Merkle tree we use in situation when memory efficiency is more important than like raw speed. The next feature of Zerokit, we use different ZK format. For ZK proof, it's actually grows 16. We have to load like ZK and verification K, and it's usually some big data. And usual ZK format, it's really heavy and long to read, but it's easy to use because it generates like automatically when we generate witness and prepare all data for sockets. So we support ZK format. It's easy but slow, and also we support ArcZK format. It required additional conversion before start, so we have to change. You have to do it like only once, and then you can use it, and it works much faster. Also, Zerokit FFI friendly and provide API for all feature above. You can use like another language, not only Rust. Also, we use Circum-based circuits for Erlang. Now it's IDEN free. We calculated by IDEN free because it's much faster than it was with Arc Circum. And we had Rust support, but we deprecated it for version 0.7 because of some of the problem. I talk about it like next minute, I think. And now in latest version, like last week, we published new release and we return Rust support back. So it's allowed to calculate witness in web. And now let's talk about what new we have in new version. As I said, we already had Wasm model. It was originally built with Wasmer, and it has like some drawbacks, like it's difficult support for some compatibility issues. So it uses some old version, it's hard to build, it doesn't support something new, and it has a lot of problem around it. But what is more important, it was really, really slow. And we even cannot use any prior execution, and it was a big issue. So we decided at first to fully remove it because we didn't understand how to like fix it like as it model as it was. But now we return it, and moreover, everyone loves numbers. So now I show how we improve our performance. I don't know if you do you see my mouse? Okay, if not, I can like talk about number. So in latest version, we have proof generation takes more than 1 second. Proof verification is much faster, but it's always fast, but it's still 10 milliseconds. In current version 0.8, without any features, proof generation take less than seconds, around 800 milliseconds, and even verification We also can use some additional features, as I said. The first one, we can apply RZK. So now we have the same time of proof generation verification, but building RLN become much, much faster. So let me return a little bit back. Here it was 10 seconds, here 2 seconds. Now it's only 70 milliseconds. So it's pretty good, I think. And even more, if we add parallel execution, we have for around 4 times faster RLN proof generation, and also we have similar number for proof verification. I think it's really cool, and it's much easy to support and use it. And yeah. Okay. Next problem, it was with Merkle tree. It actually was found by Vac team because they use Zerokit, and when they started to calculate a really big tree and recalculate it, so Merkle tree, it's actually operation with a lot of. We had a lot of heavy and slow operation. So in current release, we focus to solve this issue, improve our Merkle tree computations, and our team improved performance of hash recalculation. And also, we also add some parallel computation for both type of trees. And as a result, we improved around 2 times override operation for the full Merkle tree, and also around 2 times operation for the optimal Merkle tree. Okay, I think from my side that's all. We will be really happy if you will use Zerokit, if you will return to us with any feedback, and maybe you want to participate in Zerokit. In all slides, we have links, some open issues, or even you can write me or anyone in our team, and we can say how you can help to us. Thank you.
Thank you, Ekaterina, for the nice presentation. Here. Yeah. Welcome to second half of the presentation. I will present about the applications of Zerokit and a little bit of further directions and some of them in the explosive research. And here's my outline: gasless L2 by help of RLN, and some future directions like RLN v3 and EDDS identity, signature like RLN and two-tier RLN. And these are the future directions that is not capable of the current Zerokit version 0.8.0. Yeah, just a small recap, and let's skip past since Ekaterina is mentioned this. The main usage of RLN is actually for rate of the number of message. So the rate in here is a number of message. In the network, you just buy the rights of the number of message, and you can just safely enjoy your free messages. I mean, the free means you can consume it in a secure way, and unless you exceed the number of message. And it looks a bit trivial, but in the future I will jump to another topic. So that's why I wanted to recap again. So, especially you are in the network that has the sender anonymous and decentralized, and this fits is very cool, and because of the number of message, that's why Vacu is one of the message protocols inseparable between the Vacu and RLN. But we can also use the RLN for the gasless L2 creation. Before jumping on the gasless L2, I would like to ask this question: what is gas for actually? Because we need to replace the Vacu mechanism. It's at least the part of it. So the gas mechanism is actually the mechanism that protecting the network for L1s usually, like Ethereum network, because since the Ethereum or the other L1s are the public computers, there might be some protecting mechanism to against the civil attacks or the malicious codes or some infinite loops or something. But this gas mechanism has also some features. For example, is dynamic. Dynamic means it regulates the activity of network. For example, this activity is high, and the gas fees are getting high, and it makes the users use the public computer less, and it's regulated. And it's fair in terms of for users and for validators. For users, for example, consider two transactions. One for is the 2K gas consumes, and the second one is the 50K gas consumes. And the first one is paid less than the second, exactly the proportional to heavy of the execution, because of the gas cost is created by the bytecode of it, bytecode of the execution. And if the execution is high, then you need to pay more gas fee based on the its bytecode. It's actually fair for validators. Consider you are a validator and you are verifying some code, and once you will validate the more and the heavier code, and which is heavy cost of in terms of gas, you need to get paid from the users too. And it also controls the block size. For example, after the 30 million gas, you can say that, okay, I just wrap up this block and no transaction can be attached more. And it also controls the block size to against bloating the block size, which might affect the security as well. So the gasless L2, we can use the LLM for usage of. We can create the gasless L2. Just a small clarification here. We don't want to remove the gas mechanism at all, and we just create another usage section with the L2. And I can divide into the LLM usage in gasless in two methods, which is current method and the future method. The current method is actually the current Zerokit. We can build this gasless L2 with the help of the current Zerokit, but future method requires some modifications over the Zerokit version 0.8.0. That's why I just created two categories here. The current method is actually based on the number of transactions, like messagings, like messages, like the appending the upper bound of the number of transactions. And for example, 6 transactions in a day. Like each transaction has the same upper bound, like let's say 200 K gas, and you have the 6 free transactions. Of course, if you register the LLM first and enjoy the 6 transaction, and if you don't want to spend more with the same registration, it goes to the spam. So the current method, as I said, is the current Zerokit is capable of creating this, and future method is actually based on number of gas unit. So, for example, we give some number of gas allocation for the peers that register in the some stake to the tree. For example, 10 M gas unit in a day. So even if in a single transaction, this user can spend all the allocations within the one or several transactions. So these are the future method, because Zerokit it requires some modification in the circuit of Zerokit. I mean the ZKP circuit of it, by counting the gas units inside of the circuit. So we have a current method flow, And actually, it has some similarities between the future method too, just some visual stuff. I will start with the creating the registration phase. It starts with the pushing some, set some rate limit R, and some ID commitment, and some fee. This fee is a stake that if there's some spam is occurred, and this stake will be withdrawn by the slashers. And then when I push this information to the membership contract, membership contract creates some tree, add this information as a leaf, and then receives back to the current wallet. Of course, the wallet requires some modification too to integrate the Zerokit backend, and just a second. Yeah, sorry. After the getting these leaf indexes or something, and core wallet takes the transaction that wants to submit it in the free gas. So before this, he just put the transaction and RLM membership information to the RLM prover, and this execution done by the browser, which is the capable of the Zerokit WASM section, as Ekaterina explains, and get back the RLM proof of the specific transaction. And this transaction is transmitted to RLM verifiers module. This module can be the part of the validators or anyone in the network that seek the spams to slash, because there's an incentivization here. So if the transaction is valid, the transaction can be go to the mempool and with a different design architecture. And otherwise, if there's a spam and any verifier, even if the validators or any node in the network can generate can extract the secret and take and withdraw the stake from the membership contract, because membership contract allows to withdraw anyone who passes the secret of the ID commitment here. Okay, let's compare the RLN versus gas a little bit. There's a compression table, which the gas features. These are all yes for gas, because these are the future of gas: protected network, dynamicity, fairness, and block size control. The current RLN is actually, and the RLN feature is protected network for sure, because there is an upper bound that all peers that can submit the transaction freely, and we can understand the upper bound of the network stress comes from the free gas. But there's a small star in the name of yes, because the RLN actually doesn't provide the proactive security, because after creating, the RLN works like this: you need to pay first, and then use your rights, and then slash if there's some spam. For example, you submit spam, and if there's no someone to slash you, it can be go to the mempool again. Or sometimes, even if you get slash, there is some mechanism to exclude your transaction from the mempool or something, because the slashing doesn't allows your transaction excluded from mempool or something. So it requires some additional stuff. That's why the small stars in here. Dynamicity means the gas cost here for gas. The RLN fees for the current and future model both is limited, because you can buy your rights, and you need to for example, let's assume the network activity is getting high, but still you have some you have some received rights to use it. For example, you buy from the less network, less gas cost, and you can just spend the next a high cost level for free. So dynamicity is limited here. For more dynamic stuff, it needs to be adjusted by modifying the membership tree, for example, in very dynamically, so we can increase the dynamicity here. For fairness, in guess, yes, it's fair for user or the validators. And underlying current, the fairness a bit low because, again, consider the 2K gas and the 50K gas. And these are both count as one, right? And even if for validators, even for users, for example, if the user just consume its her right, it just counted as one, but one of them is just spent 2K execution, and the next one is just have like 50K gas one. So it's not so it's not fair for users and similar to validators, but for future, I mean, the base on the gas cost one is much more fair because it's basically simulates the gas consumption. So it's same fairness level with the gas one. For block size control, again, there is no point-to-point estimation for the current RLN because it can be in the 0 and upper bound of gas limit of the single transaction. But RLN for future is we can have some good estimation because it's based on gas cost. So RLN future is much more appropriate to simulate the gas, but the RLN current can be some drawbacks according to the gas and RLN future. Some future directions for Zerokit, and actually we have RLN v3. A small recap: RLN v1 is one message, one epoch. V3 is X message in a single epoch, and V3 is X message in Y epoch. V1 and V2 is capable of the Zerokit right now, but RLN v3 is not capable of right now. Actually, this V3 is how we understand RLN v3. It's a bit different how the PAC understand, which is the price and scalable explorations. And for the difference, I can point out some features for or the difference of it. It's about the storage required for RLN verifiers. For example, RLN v1, consider we have n many users in the tree, and we need n slot for single nullifiers. So in total, and RLN v1 and v2, I can just empty my storage because after the single epoch there is no spam in single epoch. I just empty my storage and started to collect for nullifiers from the next epoch. For RLN v2, again, if you have n many person here, and you need to n times x storage because each person can submit the x valid nullifier. For spam, you need to detect the exact same nullifier. It means that there's a spam. And for RLN v3, you need to have n times x times y, which is allowed storage to detect the repeated nullifiers. But obviously, the RLN v3 provides a flexible epoch size. Each user can select the epoch size to best fit their specific requirements. For example, some users interested in AMMs, some of them is on-chain game, and some of them just very beginner users, just a few transactions in a in a day, maybe in a week, and it makes great more flexibility. Otherwise, RLN v1 and v2, you need to obey that how the RLN developers set the epoch size. If it's minutes, there's no any flexibility. You need to obey. You need to get your requirements in terms of a single minute. Yeah, the next topic is about the EDDSA identity. It's actually how the PSC, it comes from the PSC version LLM v3. And this is not capable of Zerokit yet. So for understanding this, let's jump into how the current LLM identities works. Firstly, I just pick a random number X and take a hash of it, and I can calculate the identity commitment of this hash of this X. So this will be my identity commitment. But if they say LLM identity, take the X and calculate the G to the X. This G is the generator point of the elliptic curve. Since it's EDDSA, it can be the one of the Edwood curves. So it outputs an X coordinate and a Y coordinate, and the identity commitment will be the hash of it. So if you recognize this is actually the public key of the signature. So the motivation behind using the EDDSA identity regarding to the hash of X is proving the identity if it's necessary. So if in the settings, I mean the hash settings, there is no way to prove the hash belongs to you because you cannot share the X except secret and should be secret. But in here, maybe you can use ZKP, like the pre-match proof of X. But in here, you can just sign for a specific message in a very lightweight mode without using ZKP or something. Just take some message and sign with this X, and everyone can prove that with your identity. But of course, it may reveal some information of you, which is I want to use. The people may want to use RLN for the privacy preserving features too. But yeah, if you combine your RLN with the different applications that you need to prove your identity, the EDDSA RLN identity can be good for this. And the next future direction is about the signature like RLN, which is highly exploitative. And the aim is actually create the RLN proof without ZK. It's a bit huge, but if you consider to light users or some constrained devices users, and it's not possible to use especially in gasless L2 settings in the browser or something. So if we have some way to create a RLN proof without ZK, it can be good. But in the literature, it's very limited to. There's no practical applications about the private delegated proof to the prover, but that's why we can have some assumptions in here. For example, we can just have one-time signatures. Even if the prover can be the malicious, the prover just can create the single time signature, single time RLN, nothing more. So maybe we can just we can use like primitives, like a lightweight commitment schemes or something. Then we can create, and with this we can just delegate the proof to the external provers, like third-party provers, and it makes more efficient for the constrained devices users or lightweight users. Actually, one RLN circuit consists of three big, this should be three, and three different sections. These are the left sides. These are the inputs. This is actually based on V2. The first tree is the private inputs, and external identifier and the hash of signal, hash of transaction maybe should be public, can be public, and it creates some y value with this stuff and create nullifier and proof. 3 big executions as follows. The first one is verifying numerical proof, and we can handle this by using the ED, like ED RLM v3 ED DSI identity approach, because the proving of holding the secret number can be proved by the signatures, which is actually the definition of the digital signatures. So in the signature-like mode, we can verify the random number we hold is actually same as with the users registered in the registration phase. But the message ID range check, which is necessary for the message ID, otherwise the RLN verifier owner can cheat the protocol and also correctly calculate Y and the nullifier is also very important for security of RLN. So these are the bottlenecks and the possible hard topics against the signature-like RLN. So what if we have the signature-like RLN with the transparent middlewares? Not have to be fully transparent, maybe just the mitigate of transparent, so because of the reality. So the registration phase is still the same as the classical RLN, and we get the leaf index and the related information. Then we just create some metadata for the specific transaction hash of it. So we can just get the signature of the RLN and we can just send it to the prover, and the prover makes it proves that since this require in the settings, the middleware is not mandatory, but we can just directly transmit to this signature RLN to the verifier. But for sake of the throughput and still ZK can be a good option to here. And of course, some assumptions, for example, one-time signature or the other specific primitives that the prover can prove in a faster way with a modified hardware or something. Yeah, and the last topic is about the two-tier RLN. Two-tier RLN much more doable than the signature-like, but it's a bit different than the classical RLN, even if it's a signature-like RLN. And normally in the classical RLN, we have a single limit, which is the rate limit. If there is a user that exceeds the tier limit and it's getting slashed 100%, because we just extract the secret key of it. So there's no way to getting slashed any part of it, so just a whole. But the aim, if there is the two-tier of RLN, if we can just put the second tier to RLN, it helps to the first tier can play a role the warning of getting slashed, and maybe we can have just a small slashing like 5% or something. And then if the spammers continue to spamming, maybe we can have the full slash when the user exceeds the second tier as a whole stack. For example, there's tier 1 and tier 2, and tier 1 from 0 to tier 1 message ID we can just use securely and safely. And then if the user exceeds the tier 1, it starts getting slash. But it's a good question for example, /1 and one time, and what can be the second among this area. Maybe this is just consists of the single message or something. Then, or we can continue to slash and slash. And when it's reached the tier 2, we can have the full slash, sorry, and then it's similar to the classical RLN. So this is actually not applicable for the current Zerokit, because obviously it requires some modification in the circuit of the RLN. So it requires to check, it requires to range check, and of course the registration phase requires some notification for the two-tier LLM. But if there's some demand in the future, we can definitely work on it. So yeah, it's me. That's all from my end. If you have questions, we love to answer it.
Yeah, Leonard raised his hand.
So one of the quick questions I have here is around performance. Anytime we start to have proofs and have a proof server, even for Merkle tree, it costs time. Some of the use cases for, at the moment, for example, particularly around EL2, are for gaming. And gaming is notoriously responsive, fast, lots of messages, state. Is there a point at which RLN is not suitable for a particular use case because of the cost of the proof server and the volume of messages, or is it perfectly okay? I think I heard some number of milliseconds being mentioned to actually do a proof calculation. Maybe I was mistaken, but my concern is always around that balance of reliability and performance that we seek, and whether a use case is suitable. How do we work backwards and see if RLN will fit in a particular use case?
Yeah, for the proving side, it's based on milliseconds, so which is very less according to the value considered to the block size of the any projects, even if the faster one and some milliseconds is quite good in the proving side. And the verification side is actually the verification is highly parallelizable, and so we can almost have no limit to verify the stuff, verify the LLM proof, and so currently the status L2 team has some benchmark test about the verification, and it reaches very good in the single machine. And since it's highly parallelizable, and we can have almost no bottleneck in verification time. So personally, me, I don't see any kind of the bottlenecks or in proving side and the verification side. But yeah, maybe Ekaterina can say something more.
Yeah, especially for the latest version where we really improve like computation efficiency of computation for proof generation, because okay, when it was like more than 1 second, it was really a big issue because we cannot use it like in any application which require really fast like proof generation or verification. Yeah, but now it takes around 200 milliseconds. So if we use parallel computation and RxZK, and verification takes around 6 milliseconds, and I think it's pretty good. Maybe there exists some, like, I don't know, games or application where this number is still too big, but I think for a lot of applications it's all right. It's really depend on like concrete application.
Yeah, and I guess we're really good at developing software, and the question comes right to left. In my view, the use case, do we know enough about the use case that it's going to be used in to verify that? And how can we upfront, to the best of our knowledge, speak to Cyprian, the native apps he's working with, and determine before we get ourselves knee deep in a problem? We've been here before where we've developed and we suddenly found that the actual use case did not suit the technology that we have. And I'd be very keen to advance the research now, because that's 5 per second, Katerina. So that's not a lot. And when I look at the amount of users that could be pummeling in a kind of a, if I'm in a doom scenario and I'm playing a game and I'm trying to target tens of thousands of users, I could find myself in a bad place. So I'm just calling out the fact that I think we have good parameters. You are right that the technology is probably suitable for many situations where, let's say Jazz, we're talking about XMTP message sending, but that's slightly different even to a gaming situation where you're hitting messages legitimately back and forth, or you're sending emojis and likes and very small piece of data, but nonetheless messages. An emoji is a message. So I just caution against us declaring victory without actually scaling this and understanding the use cases. Thank you.
So we had requirements in terms of transactions per second that the layer 2 should be able to process. And actually, I don't have the concrete numbers, maybe, or you can quickly look them up in the requirements doc. But we still had quite some wiggle room, and we will be able to match these requirements that we got in terms of transactions per second.
Yeah, we can reach to some, I think, like a 5 or to 10K TPS. I'm not sure, but it's a much more enough for the current situation of the users, and our thesis can contain like 1 million users, and even if you can have some 1 million user with the regular users, it can enough to create, because the bottleneck can be the verification site, because eventually the single verifier needs to verify all the stuff. And even we can consider some merging the LLM proof into one, so for the better throughput, because we can just give from the computational power to gain from the time. But I think so far don't need to. We can just use some Kubernetes and create a mini sample to verify them. But maybe when speaking to the games, we can have some maybe with some multiple transactions in a single time. It requires maybe some applications, I'm not sure 100%. Maybe it can have some bottleneck in the prover side, but still with some milliseconds, it should be more sophisticated application, I think. But yeah, I'm excited to see this kind of applications to
and also adding that the sequencer will be another bottleneck in that sense. So that's likely kind of limiting throughput more. And then games would also kind of bundle these inputs, several of these inputs into a single transaction, which can help as well. So even if you're a very fast-paced game, you would not, have to do a transaction for each of those kind of inputs that you want to do.
Yeah, I'm hopeful that what we're going to have on the L2 is going to be a lot of native apps doing a lot of interesting games, but it's very low value. And when we talk about adding extra infrastructure reduces it increases our cost of running, which suddenly becomes a problem. So I think we just need to get some color on what the true demand is, and has that changed, for example, from originally? It may well have changed because there might be more hope on the L2. And again, I am hopeful that we will have a challenge here, because if we have a challenge, it means that we're actually attracting the right volume of end users, and that really is what we're up to. Thank you.
Thank you. Thank you.
If I just will jump in with a more basic general question. At the beginning, when we were talking about the various ways to represent the Merkle tree, maybe just because this might be a question that comes up when somebody listens to the recording, or maybe somebody else had that question too, is like, how do you do this without, without having the Merkle tree stored? So that just, maybe you just run through that, quickly explain, because I think that's interesting.
Okay, and now maybe Ugur can go back during the slides.
Stateless feature, right?
Yeah.
Yes, yeah.
Okay.
This one?
Yeah. I think there is not a lot of on this like slide, but still it's like good point to see it. Okay, so as I said, for Erlang proof, one part Erlang proof exactly itself, it's not one proof. It's combination of some proofs and checkers. The first proof is the K proof. It's growth 16. We generated around message, around some user like private parameters. So it's like classical ZK proof. Next part of proof. So this proof, it's allow us to check if this user is part of this group, of our group, where we wanted to have some spam protection. And next we have like some another checks, but it's not really important like for now. It's mostly to check some timestamp or message ID limit, and it's not a proof, it just checks the numbers. So Merkle tree proof actually and growth 16 proof doesn't depend on each other. So we can verify them separate, and that means it's the idea why we can separate Erlang and Merkle tree handling. So first version of Zerokit, not the first, like old version of Zerokit, when we fully support like all proofs, all verification, generator all identity, store this Merkle tree. That means if you wanna also check how many users have what's their identity, you have to store copy of this tree somewhere else. So actually for your application, you have 2 trees. Maybe, I don't know, another server, so you never see it. I don't know. And another tree, you store copy of this tree, and you also have to update it, also take some information from him. It sounds like not really efficient and not really useful for some reasons. And we decide to provide some stateless feature. As I said, for proof generation, we can separate. So we still have some private data which stores on the Zerokit side and no one never see it. And we have some data which stores on your side, for example, on chain, about identity, about this, actually this Merkle tree, about users who will have in the group. So what do you do when you want to generate proof in just for Zerokit non-stateless? You just ask, please generate proof for this message. You provide on the message and all data and identity of who you are. And we take like Merkle proof from our side. So we go to the tree, we find live with your identity, we generate Merkle tree proof, we put it like together with to you. And for verification, the same. You just give us proof, message, who you are, and we go to our Merkle tree instance, verify proof, verify the key proof, verify like all necessary check, and return to you that, okay, that's fine or not fine. In stateless feature, we don't have any access to the Merkle tree because it stores somewhere else, on chain, off chain, doesn't matter. But we still need to generate proof and verify it because like main purpose of Zerokit and Erlang set. So what we require now, you not only give us message who you are, but you also provide path to the tree and all corresponding nodes. So for example, for 3 depths 20, so I have 20 layers. 21 actually. 20 is like leaf layers if we count from 0. And you provide only like 20 elements, paths and each corresponding nodes. So we can easily also verify that Merkle proof is correct. Actually, you can do it like on your site and never provide us this information. It's fine, but we provide like both option. So main idea of your group, know all user identities, know how they store the tree, and you already have this tree, and you only wanna store this tree on chain, for example, you can use stateless feature. If for it doesn't matter how this tree will be constructed, how it will be stored, how we'll handle it. Okay, you just delegate all stuff to Zerokit. I hope this now it's make more sense.
Yeah, thank you very much for the detailed explanation. Yep, thanks. Do we have any further questions that came up in the meantime? So if not, then thank you very much, Ugur and Ekaterina, for the presentation. And yeah, thanks to the audience for the discussion and the inputs here. As always, we will have a topic in the Vac forum if you want to continue the discussion, and also feel free to reach out in the IFT research call channel on the Logos Discord. Thank you very much, and see you in the next call.